Welcome to what is probably the hardest challenge in machine learning. Yes, we are talking about evaluations. The challenge of evaluating and transparently applying machine learning models is already a hard one. However, with LLMs, we hit some more challenges along the way. In this module, we'll explore these topics, emphasizing useful metrics, renowned datasets, and strategies for making meaningful comparisons between architectures. I must emphasize that all of this information may be subject to inaccuracies. Why? Recall our earlier discussion about LLMs being trained on extensive web crawl datasets coupled with the current proliferation of numerous models in existence. A large number of the evaluations are available on the internet, so many times the community fears data contamination, where the models have already been trained on the test sets giving over promising results. A great rule of thumb is, if something is too good to be true, it probably is. Consider a model with 1 billion parameters. It may not be excellent at handling math, logic, and reasoning all at once. While this might be a bit exaggerated, you can picture similar situations with less exaggeration. A great place to verify trustable models and models that H2O recommends would again be gpt.h2o.ai. Now that we've addressed the disclaimer, let's dive into our module. We will explore essential concepts, metrics, datasets, architectures, and challenges associated with developing cutting-edge natural language models. An effective method for grasping model performance is to delve into research papers, where you often encounter comparisons with other models on various benchmarks. However, it's crucial to remain attentive to nuances. Detailed comparisons can be obscured in the fine print, as benchmarks may vary slightly in their setups. Exercising caution and thoroughly reviewing any supplementary materials or available codes is always a wise approach. Now that the disclaimers are addressed, let's explore the capabilities of Llama 2, our current leading model. Recall that GPT.h2o.ai is Llama powered. Llama 2 underwent extensive testing across various academic benchmarks, including those related to code, common sense reasoning, world knowledge, reading comprehension, math, and comprehensive assessments like Big Bench. Furthermore, dedicated safety benchmarks were employed to evaluate trustfulness, toxicity, and bias. The researchers employed reward modeling based on human preferences for optimal model selection during reinforcement learning fine-tuning. They conducted thorough human evaluations, assessing both helpfulness and safety. Additionally, contamination analysis was used to identify potential data leaks. This comprehensive approach, including academic testing, safety assessments, automated metrics, human ratings, and contamination checks, offers a well-rounded perspective on the strengths and weaknesses of the model. As LLMs become more potent, it becomes imperative to adopt similarly rigorous evaluation procedures. As for the recommended benchmark, prompts. This is a leaderboard of models we maintain and is updated extremely regularly. In fact, we use this internally to decide which models are best as well. Evaluating large language models involves a mix of methods to accurately measure performance. Automatic metrics like perplexity, accuracy, bleu, and rouge scores provide a quantitative analysis useful in tasks with ground truth criteria like translation or question answering. Comprehensive frameworks such as Helm and MT-Bench are widely used for such benchmarking. When evaluating free-form text generation, where automated metrics may be ineffective or ill-specified, direct comparative measures like A/B testing and ELO scoring come into play. A/B testing contrasts blind evaluation of responses from two different models or model versions to judge which is better. ELO scoring, inspired by chess, treats A/B comparisons like matches to compute model ratings, providing a deeper understanding on LLM performance and a means to compare models. H2O's LLM evaluation system provides a complete and accessible method for the assessment of large language models. The ranking system employed is based on the ELO rating methodology, wherein ELO scores are computed from the results of A/B tests. This procedure for ELO score computation closely follows the methodology outlined at this source. The evaluation schemes uses a test set of 60 prompts across diverse categories such as knowledge, reasoning, math, coding, writing, recommendation, and harm recognition across a variety of domains. Each prompt sets the stage for a competition between every model on the leaderboard. The role of evaluating all A/B tests is assigned to GPT-4 0613. To ensure fairness, the sequence of all possible games is shuffled and the positions of models A and B are randomized before being sent to GP4 for evaluation. A total of 1,000 bootstrap rounds are run, and the median ELO score from these rounds is considered the final score for each model. Before proceeding with the demonstration, let's see one more final consideration. Please bear in mind that there are additional intricacies involved in comparing LLM architectures. If you take a look at the image on the screen, you'll notice that whenever you scan across any new LLM releases, its attributes are measured in the following: number of tokens trained on, GPU computational power, and number of parameters inside the model. The most relevant one is the third. For example, Llama 2 7B versus Llama 2 70B. Which one do you think would be a stronger model? However, there is an added challenge with the increase in model size. Its compute requirements increase as well, and you need more GPUs to run these. As mentioned a few times earlier, it's a great idea to check out what we are hosting on our evals and GPT page, where you can decide which models to utilize. Through this systematic methodology, the H2O LLM evaluation scheme provides a comprehensive and fair assessment of large language models. Let's take a look at this in practice at our EvalGPT.ai solution. What is H2O LLM Eval Studio? It is a unified platform that offers a comprehensive suite of tools for evaluating and understanding LLMs. It enables users to assess the performance of their models across multiple dimensions, including natural language inference, question answering, and text generation. The platform also allows users to compare their models with state-of-the-art LLMs and benchmarks, providing valuable insights into their strengths and weaknesses. Let's connect on the LLM EvalGPT.ai page at EvalGPT.ai. Upon initial connection to LLM EvalGPT, you land on the homepage where the top right corner provides access to GitHub, blog, H2O GPT, and H2O LLM Studio. The left side features the LLM Eval menu, offering access to insightful pages maintained by our top developers and researchers in generative AI. These pages include ELO rankings, presenting ratings, and licensing information for each model. Clicking on a model's name reveals hyperlinks. The second page found in the menu is the evaluation method page, offering detailed information and technical insights into LLM evaluation methods, along with references to scientific literature. The third page enables users to evaluate prompt outputs, facilitating the improvement of evaluation methods through a fine-tuning process that considers user input. To reduce results, all test prompts and model responses are displayed and searchable on the prompts page. Categories assigned to each prompt are accessible, and responses can be found on the responses page. This page also provides options to select specific models, view output responses for all models, and navigate between prompts using arrows. Upon choosing a desired prompt, clicking the Show GPT Eval button allows users to compare results between two models, A and B. The resulting window displays the winner model based on the score, accompanied by an explanation for the victory. A higher score indicates better performance, aiding users in selecting the most suitable model for their business case. In summary, the process involves inputting categorized prompts, comparing models, and determining the best fit for the specific use case. If you're keen to delve deeper into any of these subjects, feel free to explore our YouTube channel, where we consistently share videos covering the most recent updates and advancements. Now that we've wrapped up this module, let's look ahead to the next one. We'll focus on practical applications, delving into how to implement these models and witnessing firsthand how the H2O AI team integrates them into our extensive generative AI platform. Thanks for watching.